Okay, now, projection. That's really what we're talking about today. Projection is really a very simple concept, but interpreting what the projection means and actually calculating the details of a projection vector, a little involved, not excruciatingly so if you develop it one step at a time. The beginning of understanding projection is being able to draw one. So, here I have, now I'm going to draw one right before your very eyes before I go over what we did. So I guess I'm going to do it up here. Here's a vector, and here's another vector. Now this looks a lot like the vectors I did here because that's kind of the way I usually draw them. That's okay, I'm going to construct it one step at a time. I'm going to project this vector onto this one, okay? Now to project one vector onto another, you draw the vectors with a common initial point. Then you go to the tip of the vector you're projecting and you draw a line segment, a little dotted line segment, which I call the projection line, from the tip of that vector perpendicular to the vector you're projecting on. Okay? So I go to the tip of this vector and I draw a little dotted line perpendicular to this one. Can you visualize the dotted line that I'm about to draw? I hope so. But here it is. Okay? And here is the projection then. Projection is just this vector from your initial point to wherever that projection line meets the second vector, okay? The vector you're projecting on. So there's your projection vector. So there's really not that much to it, although the vectors can be at weird angles and so forth, so you have to be a little careful about that. I'll actually draw a couple more before we actually get into the details of what we did in class. Now, the thing I observe about this is it's very important. This is a right triangle. If you know what this vector is, then you know the length of this side. And that's the hypotenuse. Then if you also know the angle here, you can multiply the hypotenuse by the cosine of this angle to get the length of the projection vector, or at least to get what we call the scalar projection. This angle might be greater than 90 degrees, so the cosine might be negative, so this vector might actually be that way. We'll draw one like that, don't worry about it. So again, we're just using right triangle trig. This side of the triangle is the adjacent side to this hypotenuse, for this angle. Okay, it's the adjacent side for this angle, and here's the hypotenuse. Multiply the hypotenuse by the cosine, you get the adjacent side. You can also get this side. Just multiply the hypotenuse by the sine of this angle. So we get both of these sides, and they're both important. But right now we'll just talk about the projection vector. So that's the process of projection. Now all the calculations you do if you try to project one vector and another in 3 dimensions, it's not hard, but it takes a little getting used to and a little development, and I'm probably not actually going to do much of that, at least not in the first semester of this course. Okay, but let me draw another pair of vectors. But first of all, let me do this. I want to project this vector onto this one. So I'm going to draw the same 2 vectors. Okay, but now I've got to go from the tip of this one perpendicular to this one. Well, there's no line from the tip of this one to any point on this vector that's perpendicular to this vector. But we really define it as projection onto the line of the vector we're projecting. Okay, so we're projecting this vector onto this vector. It really means we're projecting this vector onto the line of this vector. So I extend this vector, the vector we're projecting on, to a line. I didn't have to do that over here because this vector was long enough. Okay, anyhow, I do that, and then I come back here at a right angle. Now, people screw this up all the time. You have to be sure that this angle here is a reasonable right angle. So when you draw it, take the corner of a piece of 8.5 by 11 paper and see how close you are to having a right angle there. Okay, that's not perfect, but it's better than I thought it might be. Okay, so that's a reasonable projection, and our projection vector would be here. Now, you should try to trick yourself. Just draw bunches of pairs of vectors and see if you can find one that you're not sure of. And then apply the procedures that we talked about. Okay? Now, there's one other case, and I guess I'll draw one of those here. Let's take this vector and this vector. Okay? Now, when I do that projection, let's say I project this one onto this one. Well, to come at a right angle to the line of this vector, I'm going to have to come down this way, because here's the line of the vector we're projecting on. So if I want to project this vector onto this vector, I've got to have a longer line, and the line's going to have to extend in this direction so that we can bring a right angle down to it. Okay? So then here's our projection. Now notice that this angle here, we don't really form a right triangle, okay? We kind of do here, but the angle between the vectors is this angle. It's not the angle that we have here between the line of this vector and this vector. It's the angle between this vector and this vector. That is an obtuse angle and it has a negative cosine. So this generalizes things a little bit. We don't really have a triangle, but we still use the same calculations. Multiply the hypotenuse by the cosine of this obtuse angle, we get a negative. Now, what is it about this picture that indicates that we should be getting a negative? Well, in both this case and this case, the projection was in the same direction as the vector we were projecting onto. In this case, the vector's in the direction opposite the vector we're projecting onto. So, in this case, we want to really make sure we understand that we have a negative. So you want to draw a few of these with obtuse angles and see how that works. And then you take the same picture and project this vector onto this one. Okay? You'd have to extend this vector down this way and then project down like so. Be sure you know how to draw these. It's the beginning of understanding both what they mean and how to calculate them.